Okay, here we go with section 1.1, Descriptive and Inferential Statistics. I'm going to tell you what those two things are and introduce you to a few other basic concepts. First of all, a variable, in the statistics sense of the word, is a characteristic of the individual to be measured or observed. So this is a little bit different from the way you use the word variable in like algebra. In algebra, a variable is like the x in an equation that you're trying to solve for that can stand different numbers. In statistics, variables are just things that can vary from one individual to another. So that would include things like number of pets somebody has. One person might have 0. Another person might have 20, but that's something that does vary from one person to another. Favorite pizza topping. That would be an example of a variable, something that varies from person to person. Number of hours of sleep that a person got. And a college student's major. That varies from one student to another, so that would be considered a variable in the statistics sense of the word. So another thing you need to know about is populations and samples. A population is the big set of all the individuals that you're considering. And a sample is a subset of a population that's supposed to be representative of the whole population. That's important because lots of times what we're interested in is some big group of people or things that's so big and so hard to get a hold of that we can't study every single individual in the whole population. But we can get a good idea of what's true about that whole population by studying a sample. For example, imagine that we have a big bowl with two different colors of beads, maybe purple and blue beads mixed together in this big bowl or big bathtub or big swimming pool full of beads. And we want to know what percentage of all the beads are blue and what percentage are purple. Now, the only way to know exactly is to go through and count all the beads in the whole bowl or in the whole swimming pool. But we can get a pretty good idea if we mix all the beads up really well and then just pull out a handful and then count in that handful how many of the beads are blue and how many are purple. And if it turns out that, say, 60% of the beads in the handful that I pulled out are blue, then that tells us that if the beads were mixed up pretty well before we pulled out that handful, there's nothing really different about the ones that we pulled out compared to all the rest of them, then probably about 60% of the beads in the whole big swimming pool full are blue. Maybe not exactly 60%, but probably pretty close. And so this example applies not just to different colored beads, it also could be used to talk about what percentage of all the bits of cereal in a cereal box are marshmallows, or what percentage of all the voters in a certain state support a particular candidate, or what percentage of all the people in a certain area are infected with coronavirus. So if you want to know something about some whole big group, and you can pull out a handful, that handful that you pull out and actually count or measure or examine or study, that's your sample. And then the bigger group that it's supposed to be chosen from and to represent, that's your population. And we'll be talking more coming up in section 1.3 about how that sample is chosen, the methods of coming up with a sample, of pulling out that handful of beads. Let's say, for example, you want to know what's the average price of a gallon of gas right now in the state of Illinois. So the variable, the thing that varies from one gas station to another, would be how much a regular gallon of gas is priced at. The price of a gallon of gas. The population then would be all gas stations in the state of Illinois. So usually when you say what the population is, you can start it with the word all. All such and such. In this case, all gas stations in the state of Illinois. So if you are actually trying to figure out what the average price of a gallon of gas is in the state of Illinois, without having to gather information from every single gas station in the whole state, you might be able to get a pretty good idea just by looking at a sample. But what would you use for that sample? It would probably not be a good idea to just take all the gas stations in, say, the town of Lincoln, or all the gas stations on a particular street. Because gas costs more in some areas than in others. It's probably more expensive in Chicago than it is in Lincoln or in someplace in southern Illinois. It can also depend on what particular brand of gas station you go to, whether it's in an urban or a rural area, even what part of town it's in. So in your sample, you would want to include gas stations from different parts of the state, different kinds of areas, different kinds of gas stations. Another example. I read a factoid somewhere, in fact, maybe in a statistics book in the margin, that said that of people in the United States, 14% said that they feel happiest in June, and 14% said they feel happiest in the month of December. Now, what's the population? The variable is the month when somebody feels happiest. The population in this example would be all the people of the United States. Actually, after all, it talks about of people in the United States. So it's telling you something about all the people in the United States. That's the population. That's the group of individuals that this is about. But I don't think they considered me when they came up with these percentages. I don't remember being asked. Probably you weren't asked when they came up with these numbers. So they didn't ask everybody in the whole population. They just looked at a sample. What sample did they look at? Well, I don't know, but it's whatever group of people they actually surveyed to come up with those numbers. That would have been the sample in this example. Next example. Let's say a cowboy wants to know the average lifetime of horses. How long do horses live on the average? Of course, some live longer than others, but what's the average number of years that a horse lives? Well, this cowboy has known 23 horses personally in the course of his cowboy career, where he knows how long they lived. And those 23 horses, have lived an average of 18.5 years. So in this example, what's the variable? What's the thing that varies from one horse to another that we're interested in talking about? Well, that would be the lifetime. Not the average lifetime, but the individual number of years for that particular horse. It's one number of years for one horse, a different number of years for a different horse. It varies from one horse to another. So the variable is the lifetime or the number of years that the horse lives. What's the population? All horses. Basically all the horses in the world. He's talking about horses in general. And his sample is the 23 horses that he has known, that he knows about. Do you think this sample is a good representative of the population? Probably not. For one thing, it's only 23 horses out of all the millions of horses there are in the world. And for another thing, it's just these particular horses that he has known. So maybe they're all horses that live on the same ranch, that maybe have been treated better or worse than other horses. Maybe they're all the same kind of horses, and different kinds of horses live different lifetimes, different amounts of time. There's all sorts of things that could affect how long a horse might live that are different for these horses that the cowboy has known personally compared to other horses in other living conditions or other kinds of horses. So let's talk about what descriptive and inferential statistics are, because that's what this section is about. Descriptive statistics is the collection, organization, summarization, and presentation of data. And then inferential statistics goes beyond just the data you have and involves making predictions about the future, drawing conclusions about a population based on a sample, things like that. So this involves things like generalizing from samples to populations, saying what's true about the whole bathtub full of beads based on the handful that you pulled out. It includes performing estimations and hypothesis tests, determining relationships among variables, and making predictions. And this involves probability. So the way this course is organized is we're going to start out on descriptive statistics. That'll be things like drawing graphs, calculating averages, organizing data into tables and charts, that sort of thing. Then we'll spend a couple chapters talking about probability and how that works and the concepts behind that. And then we will get into inferential statistics in the last part of the course and talk about estimations and hypothesis testing and correlation and regression and things like that. So, would we be doing descriptive or inferential statistics? Which of those would be involved if you read somewhere that, say, the police in Humphreysville gave 213 speeding tickets during November 2019? Yeah, that would be descriptive statistics. Presumably, they know how many speeding tickets they've given, and they're just reporting on that number. They're telling you what they know for sure, giving the actual data. What about if you read somewhere that 45% of all smartphone users in the United States have an iPhone? Well, that's probably inferential statistics, because probably that's not based on every single individual smartphone user in the whole country. Probably that's based on a sample, and then based on what they saw in that sample, they've generalized it or estimated what's true about all smartphone users in the United States, the whole population. What about in, say, a high school chemistry class? The teacher gives a test, and then the next day walks in and says, the average score on this chemistry exam was 79.5. Would that be descriptive or inferential statistics? Well, if he's got all the data, all the scores for the whole class, which is everybody he's talking about, everybody he's concerned with, and he's just taking all of those scores and averaging them together and reporting on what the average is, that would just be descriptive statistics. He's not going beyond what he knows for sure. He's just reporting on the average of that set of data. What about if you read that, say, from past figures, it has been predicted that 39% of registered voters will vote in the next election? Well, yeah, that would be inferential. They're trying to make predictions on what will happen based on past figures. So that's section 1.1. I'll stop this video here and come back in the next video and talk about section 1.2. See you then.